Welcome back and welcome to section 4. In section 4 we're going to have an introduction to variables, data types and some simple data structures, as well as some examples of how we can process each of these. So welcome to video 1, data primitives. In this video we're going to take a look at the most basic data types available to us in the Java programming language. So Java has something called primitive data types. So primitives are the data types that are not objects. So pretty much everything we've dealt with so far, we've been talking about objects. But you may notice along the way we've defined things called ints. Ints are primitive data types, one of the few primitive data types available to us in Java. And actually they're the only data types in Java that are not objects. Essentially the data types that are baked into the language. They're a core part of the language, and they represent the lowest level of data type available. So although almost everything you interact with in Java is going to be an object, actually if you go far enough down the object tree or through the inheritance graph, you'll find that ultimately everything is made up of primitives, although people have built a lot of things on top of that. So what are the primitive data types available to us? Well, first of all we have the byte, which is an 8-bit signed 2's complement integer. And it's often useful for saving memory with really large arrays. So quite often if you receive some kind of buffer, some kind of memory buffer or some kind of data buffer, it will be a byte array. And that's because an 8-bit integer is sufficient for storing the element in the array. Now we also have 16-bit signed 2's complement integers. They're called shorts, and they're also useful for saving memory compared to an int, because an int is actually 32 bits. So if you create an array of integers, you're creating an array of 32-bit values. So 32 bits is 4 bytes, so that's 4 bytes per entry in the array, which of course is 4 times the size of a byte. So often you'll find byte arrays are used to save memory. If you're storing ints, then most people will just use an int. Modern computer systems have so much memory that actually the difference between for most applications between using an int, a short and a byte is actually pretty insignificant. So an int is a 32-bit signed 2 complements integer. However, in Java 8 you can actually use this as an unsigned integer for greater positive range. So what this essentially means is you've got 16 bytes or 16 bits of positive range and 16 bits of negative range by default. In Java 8 you can use all 32 bits for positive range. If you need even more space for your numbers, you can use a long. A long is a 64-bit 2's complement integer, and in Java 8 that can also be unsigned for even greater positive range. So you can use all 64 bits or all 8 bytes for the positive part of your number and none for the negative part of your number. So that's useful if you're storing really big numbers. Next we have a float, and a float is a single precision 32-bit floating point number. So that's for non-whole numbers, non-integer numbers. And we also have double precision, which is 64-bit floating point. So if you have anything that's not a whole number, chances are you're going to use a float or a double. Of course, we also have a boolean, which you've seen, which is just true or false. And then we have char, which is a 16-bit Unicode character. A char is a single character. Now you'll notice I haven't included a primitive data type, or there isn't a primitive data type, for a string. So what happens if you want to store some text? Well, string is not a primitive data type, it's actually an object data type. Now under the hood, a string is made up of chars, but there's no string primitive data type. You have to use the string object. So let's go and take a quick look at what each of these data types look like. A brief hands-on demo. So if we flick over to IntelliJ, in IntelliJ, under the code examples, if you look under product 1, under data types, I've got a class called primitives. I'm just going to close the other tabs. And in here, we've created some sample primitive data types. So we've created an integer with a value of 100, an int, double with a value of 3.142, a float with a value of 3.1414, and we signify that that's a float by putting an F after it. If I remove that, it thinks it's a double, so it defaults to a double, so you have to put an F. I've created a long with a value of 1 million, a a boolean with a value of false, and a char with a value of just C. And what we can see here is we can actually interact seamlessly between data types. So we can do integer times double, we can do long plus float, etc. We can also obviously print boolean and char out. So if I run this, we can see that 100 times 3.142 is, unsurprisingly perhaps, 314.2. We can add long and float together. So if we add 3.1414 to a million, we get 1 million and 3.1, and the rest is sort of truncated. If we print boolean false, we get false, and if we print C, we get C. So that's pretty much it for primitives. These are the most basic data types. And you'll notice that unlike a primitive, which is typically named, unlike a class, which is typically named with a capital letter, like the string type here, primitives are lowercase. So int, double float, long, boolean, char, they're all lowercase. If you command click on them, you can't see the implementation of them. That's too low level for the IDE. However, if we command click on string, we can see how that's implemented. So we can see here how the string class is implemented, which is quite nice if you're interested in that sort of thing. So we can see what it's made up for. The string class represents character strings. All string literals in Java programs such as da-da-da-da-da are implemented as instances of this class. So a nice thing about Java is, and we're going to see about this in the next video, we can actually switch seamlessly between primitive and object-based data types, some specific data types. So we can actually do, we can define a string like this with quotes, blah, blah. And that's actually an instance of a string. So if we do my string equals this, it won't work. But if we do string my string equals this, we can define it purely using quotes. Now recall, for every other type of class, we would have to do something like string my string equals new string blah blah, which is not actually required. New string, let's call that. So that will work, but basically the language has an abbreviation built in, so you don't need to do that because it's such a common operation. So you can look at this, you can look at some of the comments, you can see who's been involved in writing the string class. You can see what makes up a string, hashes, coders, all sorts of clever stuff, and perhaps more interestingly, some of the methods that are available on the string class. So we can see a string is, unsurprisingly, an array of chars. We can check the range on a string, we can do comparisons on a string, we can get the length of a string. This is quite interesting just to read through here. You can get offsets and all sorts of things. It's because it's an object, the methods are much more powerful.